Welcome to the Analytics Engineering Podcast, featuring conversations with practitioners inventing the future of analytics engineering.
On this episode, Tristan and I sit down with Jerry Liu, who's the CEO and co-founder of LlamaIndex. LlamaIndex is an open source framework that helps people prep their data for use with large language models in a process called retrieval augmented generation. LLMs are great decision engines, but in order for them to be useful for organizations, they need additional knowledge and context. And we talk about how companies are bringing their data to tailor LLMs to their needs. This is a really fun episode because Jerry is incredibly knowledgeable, and we get to hear from him on what's happening with vector databases, fine-tuning models, retrieval augmented generation, agents, and more. If these words are new for you, fear not. We'll explain all of this during the episode.
And maybe in more depth than you wanted. I use this episode as a shameless opportunity to learn from a real expert in some of these techniques. I mean, I really think that the innovation in product space in AI is really happening around what happens after you have the large language model. Like, how do you take it and customize it for a specific use case? And I feel like I've never had anyone explain the inner workings of how that happens better than Jerry.
Yeah, I think most people get first exposure with LLMs through ChatGPT, which is like a consumer interface, but it's an entirely new way to develop applications for organizations. And Jerry does a really good job of like explaining what needs to happen in order to bring that like additional context and knowledge to the LLM so that you can use it for your business. And he helps demystify a lot of what's happening underneath the hood. So it's a really fun episode. Also got to learn a lot. And without further ado, let's get into it. Awesome. Welcome, Jerry, to the show. Today we have our guest, Jerry Liu. He's the CEO, founder of LlamaIndex, and he's been working in a really interesting space to help people get their data in a spot that's ready to be used by LLM applications. Before we jump into what specifically LlamaIndex is doing, Jerry, I would love for you to just introduce yourself, say hello, and how'd you get into this space?
Yeah, sounds good. First off, thanks for the invite. It's great to be here. My name is Jerry. I'm co-founder and CEO of LlamaIndex. I've spent the past few months working on this project, and as a company, it's been around for about 3 months. I've spent most of my working career in AI, machine learning, and kind of the intersection of that, plus research and also product. So before this, I spent 2 years leading the monitoring team at Robust Intelligence, which is a startup focused on MLOps, like testing, validation, and monitoring. For that, I've been over 2 years at Uber ATG doing self-driving research. And then also spent some time as a machine learning engineer. And so kind of at the nice intersection of all these skills now that, I'm trying to run a kind of AI company that's building products that's supposed to be useful for developers.
Jerry, did you say that the company has now been around for 3 months? Did I hear that correct?
Yeah, we incorporated the company in April. Yeah, but the product has been around for about 8 or 9 months.
Which, 8 or 9 months, that makes you one of the longest lasting AI products in the market, I think.
Yeah, given the current time scale of things, definitely.
I want to hear a little bit more about your time from like Uber and trying to work on autonomous systems there. I found that a lot of people that were drawn to ML and AI spent a lot of their efforts initially on like the AV evolution, and maybe now they're focusing more on LLMs. Is there any translation there of the work experience to get an autonomous system with a high enough quality and accuracy to production compared to what you're working on now with LLMs, or are they just like two different spheres?
I think so. I think there is definitely differences, but there is overlap in the fact that a lot of the concepts do carry over. I think at a high level, like taking a step back, I think smart people want to work on interesting problems. And so it's kind of interesting to see, a lot of my smart colleagues, friends, a few years ago, like self-driving was all the rage. And so you see a lot of these like self-driving companies taking off and a lot of people getting very interested in computer vision, autonomous planning, and being able to kind of like create these vehicles. And then now that LLMs have taken off and more and more people have seen the use cases of these, a lot of these people from self-driving are now interested in working on like LLM-based problems. I think There are there's obviously differences in the data domain. Like with LLMs, it's primarily text-based. With autonomous systems, it's basically robotics and computer vision and planning in the real world. I will say AV is probably a little bit harder to kind of like showcase value just because robotics in general is a very hard problem. Being able to stitch together like all these systems to create this like working thing that operates effectively in the real world, especially on the road, is something that, has taken a few years and will probably take like a decade or more to kind of have like full autonomous self-driving. Whereas one of the cool things about LLMs, and maybe this is something that is attractive to a lot of people, is the fact that given the state of these models, it's very easy to immediately create value because you can basically just treat this as a black box in the digital world, use it to process text very easily and easily create a software system around that. I think there are some similarities though, in terms of a lot of the concepts, especially around like kind of deep learning, ML engineering and kind of like ML development practices that do carry over. For me personally, I've always been very interested in just like generative models and like in general. And so a fun tidbit is like the thing that got me into deep learning was actually like GANs back in like 2016. These were things that could like generate pretty like realistic pictures of like bedrooms and images. And generative models has kind of been this catch-all term that has encapsulated both like the image and video domain as well as the text domain. And so it's interesting seeing kind of a lot of the parallel developments in the computer vision space. You have a lot of like generative models being used in like robotic settings, but with LLMs, they're very much based on like the transformer architecture, which are generative models for text. And so it's just very cool to see how, like the intersection between these two fields.
Yeah, it's been really cool to see like crews operating around the clock now in my neighborhoods, where for those that like aren't in the Bay Area, it still blows my mind every time I see a car driving the streets with no drivers, no passengers. And people have been like wondering when was the day that we would actually see autonomous vehicles on the streets. And it's definitely happening now in San Francisco. I think you're right though, that with the like LLM excitement, it's like probably the reason why people have been able to get so excited about it today is because it's really accessible. Like you can work on problems that don't require a lot of like legislative, or maybe will eventually, but it's not the same level. It probably will have some legislative, but it's not the same level as like being able to operate a 2-ton robotic car on the streets of San Francisco. So maybe tell us a little bit about like how you got into building LlamaIndex. Like what is it? I know it used to be called GPT-Index, so it's still, you said 8 or 9 months in the making, but like what was the inspiration behind this new project?
As I mentioned, I've always been very interested in generative models. I haven't really, like I've always kept track of the developments of the NLP space. So from like the GPT-based models to like BERT to, all the way to the initial like sequence models. But I think as these models were getting better, it was clear that people were building actual applications on top of it. And so I actually feel like I got into the space like probably a little bit late. I got started back in October. I thought to myself, GPT-3 seems pretty cool. There's a growing interest in AI right now. Let me play around with it, see what happens. And I think as I was playing around with GPT-3, it became increasingly clear to me that it wasn't just useful for the inherent knowledge that it was trained over, but actually reasoning over new information. And I think that's what kind of got me thinking, well, if it's really good at reasoning over new information, the way you feed that information in is through the input prompt space, which has a context window limitation. So how do I effectively think about how to orchestrate, data flows from your kind of like source data into the language model while obeying this context limitation, but still feed like arbitrary amounts of data in so that you can build a kind of like tool that you want.
I do not understand how the sentence that you just said obeys the laws of physics. You said there's a limited context window and you want to use storage and retrieval, like vector database, whatever, to feed in additional context that allows the inputs to be unbounded. Do I have that right?
To clarify this a bit more, it's kind of like thinking you have this like limited cache space basically within this reasoning engine, within the LLM. And the LLM is basically a neural CPU, right? And if you think about a CPU, it has like some sort of cache space. But then, there is all this external data that you can imagine being, in computer architecture speak, it's like RAM or hard disk space. How do you like basically have this like neural CPU with like limited cache space operate over this external source of data, right? So even if it had like limited cache space, it could still like have the right instructions to be able to ingest the right data, understand like arbitrary amounts of large data. And so that was basically the motivation for it.
I want to break it down for people, like even maybe a step further, because our listeners maybe are newer to this space. So the challenge you're describing is that when you want to like ask a question of a LLM, there's only so much context that you can provide to the prompt. There's just like a limited number of information that you can send. And so what you're helping people do is figure out, well, that space is really limited and valuable. How do I make sure that I'm providing the right context to get the best results? Maybe like a concrete example is you have an enormous book that you want the LLM to have a context over, but you can't possibly send the entirety of the book. So how do you figure out the critical chapter to share, or how do you take a best guess on what the critical chapters are to share? Is that like a good, really oversimplification of what's happening?
No, that's 100% accurate. So the very concrete use case I was trying to solve when I was building this application was I was trying to build a sales bot that could ingest customer conversations within my previous company. And then I could have the LLM or GPT-3 ingest all this data and try to understand customer conversations so it could synthesize these inputs and also summarize like to-dos for the next meeting for each customer. And so that was a very concrete use case I wanted to try out. But as I was feeding in these customer conversations, as you said, like I quickly realized that you couldn't feed all this information into the context window of the language model, which was capped at like 4,000 tokens. And so if you had more data than that, then you needed to figure out some strategy for being able to maybe like sequentially feed information in, or basically figure out how do you like retrieve over this data to actually solve the task at hand. So that was a very concrete use case. And the reason I think I talked a bit more broadly about the general like CPU like architecture was very much like what inspired this idea of LlamaIndex was actually kind of this like grander theoretical vision of just like how do you LLMs seem like this type of like new CPU module. And so how do you kind of create this overall system around it? And that was an actual stab towards that. I can say though that the toolkit itself has kind of evolved from like an initial design of project beginnings into a very concrete and useful toolkit. And I'm happy to chat a bit more about that, about like all the value it offers around connecting data to your LLMs.
I've been trying to decide whether I want to like try to stick with your metaphor or like actually just talk about the real thing. Maybe you can make that decision, but I want to try to understand how to actually interact with a large language model in this way. So you're talking about the context window, right? So GPT-3 had 4,000 tokens. What GPT-4 is up to like 16,000, is that right?
Yeah, it's like 16,000. Quad 2 is like 100K.
Okay. So 16,000 tokens and a token is, I've heard different people explain tokens in different ways. Do you want to give your take at like, how do you quantify a token?
Yeah, a token is basically a word, or kind of like slightly more accurately, it's like 75% of a word.
Okay. Is the context window appropriately thought of as like the first prompt, or is it the sum total of all the prompts and all the responses? I think probably you should assume that everyone who's listening to this has played around with ChatGPT themselves. What stuff do you need to squeeze into these 16,000 tokens?
I guess ChatGPT has a UI interface. They do some stuff under the hood to kind of make it work with the underlying model. But I can talk about the model interface, which is at the most basic level, just like text in, text out. So the model will take in a piece of text, and then it'll give you back out like a piece of text. A lot of times when we talk about like the context window, it's basically the total limit of both the input text as well as the output text and described in number of tokens. So for instance, for OpenAI, like a 16,000 token context means that like the combination of the input text plus output text, if you tokenize the combination of that, and if it exceeds 16K, then it's not gonna work. But if within that limit, then you can actually get a result.
My understanding, based on what we've talked about so far, is that the thinking about the context window as cache for a neural CPU maybe it does. So like you can always switch new things around in your cache, but the context window is like this fixed amount of stuff that you can never actually operate on any more than that stuff. Is that correct?
I think so. Maybe a cache. Yeah. I mean, it's all these analogies like have some limitations to them. But the idea is that the context window is basically like some scratchpad, or like the thing that you can actually fit in to basically get some output from this like neural CPU. And so if you think about it as this like big scratchpad, you can't swap it in. in and out stuff. And you can also chain calls together, right? Because you can like do some initial call. Maybe that initial call is more like to get instructions about where things are located. Now that you have information of where things are located, you can then use this input prompt space again to feed in some information and then have it to reason over a new task. The idea is that given some input, it's like a unit of compute execution over this input to give you some output. And you can basically, figure out some sort of outer loop or software system to use this module to create some like higher order reasoning logic.
Thank you. That is, I don't know how long we just had that. Maybe that was like 4 minutes. That was like the most succinct 4 minutes that I've ever had at like understanding like another layer deeper here. So thank you.
I will say though that if we talk very practically about the current stacks that are emerging, we can start from the basics. Like, I think that this idea of just like using an LLM, this like neuro CPU, there's some architectures like agent architectures emerging that are basically using as such, that can basically do kind of like iterative reasoning and kind of like unbounded, like basically like automation over a variety of different tasks. But if we just stick with like a core architecture of like a lot of what retrieval augmented generation is, or like, for instance, like what people usually go for when they want to build like a LLM application over your data, it is pretty basic. It's basically just like 2 steps. Given some sort of like knowledge corpus, for instance, in a vector database, as you mentioned, you would first do like a retrieval step from this vector database. And step actually doesn't require the LLM at all. That's just querying the vector database to retrieve the most relevant content based on embedding similarity. So that's basically just using a vector database. And now you have this like set of retrieved data from the vector database. The next step is the synthesis. So given the set of retrieved context, then you figure out a way to put this context into some sort of input prompt for the language model, so that it can basically answer a question given this context. So it's really just like a 2-step approach. And it doesn't really make use of full on like, using LLM as a neuro CPU and this like reasoning loop. But even that very basic stack is still very useful for a lot of users.
Yeah, one of the most simplifying ways that I like to think about it is like the LLM is your decision engine. It's been trained with a lot of information at a point in time, can have like cognitive abilities to reason about the prompt, but it only knows like what it's been trained on. And that's like public information at a point in time. A lot of public information. It's like very impressive what it can do on its own. But in order to like provide your own context about your business, you have to retrieve the appropriate either private information or the relevant kind of proof points to the decision engine so that it can reason about what a good output or logical next step might be. The cool thing that just because our listeners would understand this, like when I first heard about GPT index or now called LlamaIndex, people said it was like the 5-tran of LLMs, which is like, how do you get data from its source properly, get it in the right format, which in LLM applications, it's chunking it up and storing it in a vector database and then retrieving it appropriately for use of whatever application you want to build with an LLM.
That's a good way of describing that. It's an interesting analogy. I think these days I like to think LlamaIndex probably is a bit of a broader framework and purely the kind of like ETL or injection layer. But the overall mission is exactly as you said, is the idea of LLMs by themselves have a knowledge cutoff date so that you can ask them questions about certain things, but they would only know what they're kind of like publicly trained on. So a lot of the value in LLMs is being able to unlock the reasoning capabilities on top of your own private sources of data. And to do that, you basically want to do what we've been talking about, which is set up some sort of like data pipeline and create this overall software system between your data and the language model to solve any input task that you have at hand. And so we provide all the tools to allow you to do that, from the ingestion, indexing, basically the ETL side, to also the query layer. And so once you've actually ingested this data into the storage system, like a vector database, we also provide you the capabilities to do any sort of retrieval, synthesis, and reasoning over this data using LLMs to actually give you an answer.
It's, I think, pretty clear to me that a lot of the value of LLMs is going to come from applying the reasoning capabilities to private data. And so I've been interested in the answer to the question that you just answered for many months now. And it's not new information that this is the good solution to that problem. My very naive read here is that it seems like a funny version of a solution. My real question to you is like, do you feel like this will still be the way that we do this in, I don't know, 2 years? Here's why I feel like it's kind of funny. Okay, you've been using the neural CPU. If instead of using the comparison to a computer, you use the comparison to a human, which is, something that it's a common way that we are using this metaphor for these things. The way that it seems like you're suggesting the architecture should work is that our brains are reasoning engines, but they don't actually contain any. Most of what we're doing is not trying to use the facts in our brains. And so we load new information in our brains. We read a book, and then you ask one question, and then you answer that question, and then you forget everything that you just learned. And you move on to answer some other question, which is a weird process. Are there other approaches to this problem too?
Yeah, absolutely. In a lot of these talks, when I talk about framing LlamaIndex or this problem set, actually, of how do you get LLMs to access your data at a high level, there's really two approaches. One is exactly what I talked about, which is this idea of setting up some sort of data pipeline or for in-context learning. And in-context learning is just a fancy word for figuring out how to stuff stuff into the input prompt so that you get back some and creating a software system around that. The next part is actually more on the model architecture side and training side. So how do you actually, the reason ChatGPT is very powerful is this black box thing that uses some sort of gradient optimization to actually, underneath the hood, it's just a bunch of numbers, weights that power the model, and it learns over a data corpus. And then because it learns over a data corpus, it can now answer a bunch of questions about this data corpus. So these days, there's a lot of growing interest in stuff like fine tuning, training in general, and also model distillation.
Can you define model distillation and fine tuning for our users?
Yeah, absolutely. There's first model training, which is you have this model. It's initialized with some random parameters. So by default, it will just output random noise. And then you have some sort of training process. This is how GPT-3 is trained. You give it some data and you train it. And then now it's GPT-3, right? It can now understand this data and take in some input, give you back comprehensible. So fine tuning is basically the process of, there's a variety of ways to do this, but you take a model that's already been trained on some data, and then you figure out a way to train it more on some new data. And so let's say you could have this model be trained more on some data that you own as an individual or an enterprise. And that's what you call fine tuning. There's different ways to do fine tuning. If you imagine let's just take GPT as an example. You imagine the entire architecture. You could fine tune all the weights. That will be expensive and slow. Because then you're changing everything, basically. You could fix part of the weights and just fine tune some sort of layer on top. That is another example where you basically take advantage of the fact most of the representations have been learned during the kind of pre-training process when GPT was trained. But then you also want to fine tune this additional step to actually learn over your own data representations. And then there's some other variants of what I just said. And that's basically what fine tuning is. Model distillation is this approach of taking a bigger model and distilling, quote unquote, into a smaller one. So training a smaller model to basically imitate a bigger model. This can be useful because it's basically a form of compressing a lot of information into something that's cheaper and faster to run. For instance, if GPT-4 has 1 trillion parameters, you want to distill GPT-4 into kind of a smaller model, maybe that has context over your data. You could try to do that. And so I think a lot of, some companies are very interested in saving on, for instance, cost, hosting and latency. And also they don't want to pay OpenAI money. And so, you can try to distill this bigger model into a smaller one that you can then host or just run a lot faster and cheaper.
I would have to imagine that for people constructing systems and for people building tooling to allow people to construct systems, it is a very interesting question. Which one of those approaches is most relevant for a given problem space?
100%.
Is there a map of what is most appropriate in what situations right now?
When I talk about these two approaches, I think honestly, the jury is still out because the research space is moving very fast in terms of the capability and power of fine tuning, as well as kind of new discoveries around this idea of retrieval augmented generation.
So both sides of this coin are getting better at the same time.
Yeah, people were creating new software systems around this idea of kind of in-context learning. A lot of agent-based stuff is basically just fancy ways of in-context learning. And then there's been a lot of improvements in terms of fine-tuning techniques to make it better, faster, cheaper, more efficient. If you look at a lot of slew of like open source models that have come out these days, like open source LLMs. A lot of them are just like fine-tuned variants and using kind of state-of-the-art techniques like LoRa that basically make it a lot faster and cheaper for anyone to fine-tune. There's a huge incentive from both sides to make both of these techniques better, because the end goal is to make LLMs and kind of like access to your data more accessible to everybody.
Isn't there like a step function change though in cost? Like it's easier to get started with retrieval augmented generation because you have the data stored in a vector database and you can build some tooling around it. Whereas like the cost of training a model can be like wildly expensive depending on what you need it to accomplish.
I think so, but I think these days fine tuning has, there's been claims by some companies like, oh yeah, like you can fine tune a model with like $10, right? In the end, if it's like $10 of your data set, that'll, I'm sure.
It's cheaper than my coffee
Yeah.
in San Francisco.
But I think like back to your point though, it's not just about performance and cost. Actually, I think probably the biggest thing that's motivating a lot of people, like actually most people are not doing fine tuning these days. Probably the biggest reason for that is like the UX and ease of use. Most people don't know how to do fine tuning, or they don't know how to do it well. And just like the interface for doing it is not very accessible. OpenAI's fine tuning API is not great. I'm sure they're improving it. I think they are improving it.
It feels like retrieval augmented generation, the skill set required is a little bit more like software engineering or data engineering, whereas fine tuning, it's a little bit more like machine learning or data science.
That's exactly. And so one of the beautiful things about LLMs and the applications built on top of it is a lot of the hype around it is the fact that you've kind of opened this technology up to just like software developers as opposed to kind of restricting it purely in ML space. And so for the vast majority of users using tooling like LlamaIndex, LangChain, other stuff like to kind of build these software systems is way more accessible.
So it's very much like an art and a science right now to get your data prepped for use with an LLM. And we've gone through a number of the steps today, but it's likely you have to go through kind of contorting your data to like fit the context window as we discussed. If the context window gets really large, like Anthropic's Claude has 100,000 tokens input, do you have to go through this massive data prep process to still supply the right data, or are we still like in the very early innings and we just can't imagine what the next stage of retrieval augmented generation might look like?
Yeah, it's a very interesting question to some extent. I think it's both. Like I don't want to kind of bet on the current paradigm of like the thing that's going to carry over into the future, especially as these models not only have like longer context windows, but like for instance, like the architecture has also changed. The models might have like inbuilt memory systems. The costs for kind of like inference might go down dramatically. I think as it stands right now, even with something like Anthropic Claude 100K, it certainly opens up a nice option for a lot of users, but there is a very real trade-off between cost, latency, and performance. If you ever played around with Claude 100K, if you stuff everything into the context window, it takes about 60 seconds for you to get a single inference call, which is just infeasible for a lot of applications.
This October, join data practitioners at Coalesce, the analytics engineering conference hosted by TBT Labs. It's built by data people for data people. Register at coalesce.getdbt.com with the discount code podcast23, just for our listeners. That's podcast23 with a capital P. We'll see you there. Can we talk a little bit about like some of the other components of, I'll call it like a pipeline to get your LLM application together?
Are you going to ask about vector databases?
I am, Tristan.
Great. Let's do that. Because I just don't understand why we don't use Postgres.
That's my question.
I just want to be the grumpy person in the room.
So the vector databases have had tremendous amount of success recently. Like there's Pinecone and Chroma and Weaviate, the whole host of options there. And they're doing really well because people need to store embeddings and search in vector space, like similarity. What is the most appropriate thing that I need to retrieve to stuff into my prompt? One is like, how does the vector base differentiate? And do we need a special purpose built vector database? Or are we going to see like Postgres with PG Vector really start providing an alternative to a whole new architecture?
Yeah. To some extent, I might not be the best person to answer this because from our perspective, we also want to We partner with pretty much every vector database, from the PG vectors, Postgres to the Chromas, Weaviates, Pinecones.
I've given this answer before.
Yeah,
I know your
sounds
position.
familiar. We love them all.
I mean, I think to think about this a bit more, though, the first part is like, yes, I think a lot of people with Postgres are just using PG vector, and I think it's a very valid concern for these vector databases. I think you will see vector databases start either competing or differentiating in like a few dimensions. One is a pretty big one is like inference speed and cost, basically. So yes, like maybe PG vector with Postgres can get you results in like, 500 milliseconds, but maybe like, Pinecone can get you results in like milliseconds, right? This is just an example, like, just like very optimized for this task, embedding based lookup and retrieval. The other piece here, though, is that I think vector databases right now are a pretty simple instantiation of how you can build some initial like LLM pipeline. But there's a lot more improvements to be made on the query interface for any sort of storage system that you'd want to like build an LLM application around. And the way I say, so for instance, like one thing that some vector databases have added is not just like pure vector-based lookup, but actually you can actually, filter out certain items with like metadata tags, right? And so I think like this adds a layer of sophistication to being able to like query for things in a vector database, because now you can basically have filters that can better prune out certain results and kind of increase the precision of your retrieve results, which will then help like your LLM RAG system. I think you'll start to see kind of like more capabilities, kind of like this, where you're going to have like parameters that will basically aid in retrieval specifically for LLM application use. And these are parameters that not only like a human can infer, but like an LLM can infer as well. So actually one of the cool things that we demo with LlamaIndex is the fact that through an interface like this with a vector database, you can actually have the LLM, given some sort of user question, infer not just like the query string that will be used for embedding lookup, but actually any additional filter tags. And this can help like improve the retrieval results.
The craziest thing for me is like, there just seems to be like no limit to what LLMs can do. Like they also are like helping self-evaluate, like how effective was my LLM at answering these questions? Instead of like having a human do that process, can I have an LLM, like a reasoning engine, evaluate accuracy? What are maybe some examples that you've seen of like companies being really successful at building like an end-to-end application live? We see a lot of companies come to us with curiosity of how can I ask questions of my data in natural language and have an LLM like respond with an accurate read of the data. And we've seen some like pretty exciting prototypes, but not yet things that are reliable enough in production. I'm curious to get your takes on what has been exciting. Where do you think the use cases will end up going?
Yeah, it's interesting. I think if we talked about this like 3-4 months ago, I would have like basically 100% agree with you. I think these days we're actually starting to see more and more companies like putting out LLM features in a production set, like production, as in it's actually user facing. But I will say that reliability is a big issue, and that a lot of the stuff that companies are putting out these days are more constrained workflows. The way I think about this is there's a whole spectrum of LLM applications that you can build, from stuff that's very constrained to stuff that's very unconstrained. Stuff that's very constrained is like simple like QA over your data, and simple like chatbots over like specific stuff, sources of data. They're constrained because these LLMs can't just go off and like perform random actions in the real world. They're very much restricted to the task of, hey, just analyze this document or answer this question about the data. And for instance, like with a retrieval augmented generation pipeline with a vector database, we're starting to see quite a bit of that. Probably like 50 to 60% of like enterprise users we're talking to have built some variant of a chatbot that they're planning to release to users, and they actually just talk to like a few users like these past few days that are putting these chatbots in production, and some of them are using LlamaIndex. I think where you're starting to see people like more in the prototyping phase and not really sure if it's going to make to production is on fancier unconstrained workflows. And this is stuff around like agents. So basically unconstrained like orchestrators that can fully take advantage of the reasoning capabilities of LLMs, reason about things in like a sequential chain, and not only just like read information from a specific data source, but from like a diverse range of tools and actually perform actions on behalf of the user. I haven't seen as much of that in production. And the reason I haven't seen that is I think these days, like agents are still lack a certain quality of reliability that probably users expect to actually make this like a useful feature in production.
I'm curious if you think about maybe a couple buckets of areas that are going to have the biggest impact in increasing in quality improvements. Like, is it going to be on the model layer? Like, do we just need more evolved, better models that have better reasoning capabilities? Is it going to be on we discussed a little bit, the vector databases? That might not be the biggest requirement to get higher quality, but like, is it tooling? What do you think needs to evolve to get to the quote unquote like promised land where these LLMs are not just in constrained environments, but like helping solve very like common tasks for organizations?
There's like a growing sentiment these days that the future of like LLMs and agents is actually going to be like a kind of multi-agents. And so that you're actually cool with living in a world where like you're going to have like different LLMs and agents like specialize in different tasks as long as they can kind of like communicate with each other, either kind of like peer to peer or like just in some sort of like hierarchy. The reason I say this is that's, to me at least, that's actually an easier problem to solve than trying to have like general things that can do everything. And I think, you know, even intuitively, if you think about like humans are general intelligence, like machines basically, but they tend to specialize in things, right? Like a software engineer is going to learn coding skills, like a musician's going to learn like a certain instrument. And so I think it's easier for like an LLM to be constrained and be very good at like certain tasks. For instance, maybe this like agent is very good at like sending emails and scheduling things for your client, but you know, it can basically kind of like communicate with other agents through some sort of API interface. And so I think like that world to me seems more practical and feasible because it's just realistically what a lot of people are going to build. And as users not only use technologies like GPT-4 or kind of these general LLMs, like general pre-trained LLMs, but they also try to like fine tune these LLMs on their own private data, they're going to start building these like baking in AI and LLM workflows for these like constrained tasks. So I think it's basically going back to your question, like what's going to create these like improvements in reliability. I think it's going to be like twofold. One is that the model technology will get better. So as reasoning capabilities of these big models and also open source models get better, more and more people are going to be able to just build reliable stuff pretty easily. But I think the other part is really proper like software and API design between different agents. And so if we can actually kind of create these good interfaces where people are building these like specialized LLMs and agents for these different tasks and also design good communication protocols between them, then I think, you know, then you're going to start to see kind of like greater capabilities come about, not just through like a single kind of LLM or agent.
Do the agents need APIs or is the API just text?
Actually, yeah, it's a good question. If you think about just very practically how an agent is implemented these days, for instance, if you've heard about like the OpenAI function calling API or even just like a standard React agent, an agent is basically a reasoning prompt with an LLM that has access to like a set of tools. And it can choose to call like these tools. And by calling it just means that like we'll be able to use the tool and infer the set of parameters to use this tool. And so that's basically an API call. And so by default, calling a tool could just be with text, but it could be with other parameters too. You know, like for instance, for like it could pass in like numerics, like integers, floats. It could pass in like booleans, it could pass in other strings. Basically, you know, if you think about any sort of proto file, it can like basically theoretically infer the right parameters to actually call this tool with. For instance, like another example is a SQL agent will have access to like a SQL database as a tool. And to properly call the SQL database, it will be able to pass in like a SQL statement, right, to execute over the query engine over the SQL database will execute the SQL statement and return the result. I think that's just an example of how like agents basically can communicate with each other is through this kind of like agent tool interaction. And the thing is like these tools can also be other agents. And so like, you know, that's how you can get this like communication interface between.
That part, it's like really kind of fun to think about what that world looks like. It's definitely like a mind-bending exercise.
You said fun to think about it. I was just like, oh my God, my brain is hurting right now.
these are all kind of like predictions. Like who knows what the world will turn out in like a year or two. But like I think it is fun to think about this idea of agents specializing in kind of like different microservices, similar to kind of like how a lot of infrastructure works these days, and still being able to kind of like communicate, talk to each other, and potentially like work together as part of this overall system.
Yeah, like an example might be is like, tell us who the top rep is at the company and like how much have they closed. Like you'd have access to a tool maybe on Workday to have information about their HR information, like this is an employee. Then you could query your database and say like how much have they closed on quota. So you get access to a bunch of tools. So you have to like chain together to be able to solve problems. That was not a great example, but like the tool itself could be like search to Google or search in a SaaS application or search in a warehouse. And it's these like string of things that once you get more information, you like reason about what the next step might be to take.
Yeah. And the next part of that task could be like, hey, now take all this stuff and package it in an email to like chief data officer or something, right? And so that would be, it could potentially offload to another agent or tool that can actually, send out emails automatically.
An email agent. Yeah. So we're going to wrap up here. So this has like been a fun episode because it's a little further afield from our normal users and what they spend their time working on, which is, I think, the foundation to any good LLM application is you have to have good data to be able to supply that context to power the application. So it's like a crawl, walk, run. And I think I was talking to a chief data officer yesterday, and he was really excited about AI, but he's like, we had to go on a 3-year journey to make sure our data was in the right shape. So that way we could go do this like next thing that takes time. But I was excited to bring you on to hear more about what's happening in the LLM space. But we asked this to all our guests, looking 10 years out, what do you hope will be true for the data industry?
It was great to be here. And the other piece of this, by the way, I just want to emphasize, like, we do care very much about the data and the data pipelines for LLMs. And so I think we're very aligned on this central mission. A lot of the stuff that we did talk about is very kind of forward facing, but the thing that is going to power and enable a lot of these kind of like agents or LLMs to take form is being able to kind of like create these proper software systems. And a lot of that is being able to think very carefully.
Awesome. Thanks for joining us, Jerry. It's been fun.
Thank you.
The Analytics Engineering Podcast is sponsored by DBT Labs and is hosted by Tristan Handy and myself, Julia Schottenstein. Have comments, questions, or guest suggestions? Email us at podcast@dbtlabs.com. Our producers are Jeff Fox and Dan Poppy. If you enjoy the show, please drop a review or share it with a friend. Thanks for listening.